Test, test, test.
Don't seem too close to this thing.
Oh, yeah, I think, yeah, there was something. Okay. Yeah, I guess I can hear me. It's weird though. You want me to say something? Can you all hear me? Excellent. I can hear myself too. Twice. Um, Thank you. I feel very flattered. Thanks for the nice introduction. As you said, I'm Martin. My last name is pronounced Huschenbett, if you were wondering. I'm the captain of Team DAML at Digital Asset, and I'm from Zurich. So what we're doing at DA is we're building a smart contract language. And we're not just building a smart contract language for a specific ledger, but what we're trying is to build like the smart contract language for all ledgers out there. So right now our smart contract language works on, you can run it on a Postgres database, which is not the most interesting blockchain. You can run it on VMware's blockchain, you can run it on Sawtooth, you can run it on QLDB from Amazon, and there are more, I guess. It would just end up in name dropping if I continue. You can also run it in memory if you want to, for development purposes. Yeah, and I want to talk about how we built this smart contract language. It's based on our favorite compiler, GHC. We're reusing quite big parts of it, so the language we're developing is very Haskell-like. You might want to call it Haskell for enterprises or Haskell for blockchain. Whatever you prefer. Yeah, and what I'm going to do is, first of all, I'm going to show off with like a small project we've developed based on DAML. So this is just a regular Kanban board, and it's backed by DAML, and I just use it to show it. There's no deeper reason. So what I'm going to do is, first of all, I'm going to advertise that we're looking for people at DA. So we are hiring in many roles, and one of the roles is we're looking for language engineers, so people working on the language and the SDK around it. So pretty much people from my team. If you have any questions about working for this team or for DA in general, please ask me afterwards or ask Rohan or Max. They're both working for Digital Asset too. Rohan is working in the language team, and Max is working in DAML, in the DAML as a service team, pretty much. Yeah, so, okay. Well, I said that's done. The next thing we're going to do is I'm going to show you some demo. We're going to do a live coding session, show you like how it's like Haskell, how it's different from Haskell, what you can do. Afterwards, I'll talk a bit about how we took GHC and turned it into our DAML compiler. After that, I'm here to answer all your questions about what we did, what we're gonna do, how it is to work for us, whatever is on your mind. And I don't know how you do it in New York. If there are beers afterwards, I'm happy to join. Okay, cool. So let's hope that works with the feedback. Let's start with some live coding in DAML. Here we go. It's in progress now. So can everybody, well, that's not the best of colors. Bigger, yeah, I can make it bigger. So we're not going to do much in this terminal anyway. So what we're going to do is we're going to use our DAML assistant and create a new project. Let's call it Bike Shop, because if I wasn't a software developer, I would probably run a bike shop. I'm a cycling nerd. So, and what I'm going to do in my live coding session is I'm going to like model some of the workflows you would encounter in a bike shop, or pretty much like one workflow you would encounter in a bike shop, and I'm going to model that in DAML. So that kind of like you could have like a bike shop run on a blockchain. Like if your chain on your bike is blocked, you bring it into the bike shop and we fix it. And all of that is recorded on the blockchain. Cool. So let's go into the project, and I want to show you, like, there's one feature I'd like to use which is not officially released yet, which is in the middle of being released, so we need to fuck around a bit with the configuration. So usually you don't need to do this, so we need some fancy build options. I wish I could type properly. Okay, now we're ready to write some demo. Okay, I guess that is really hard to read. Yeah, I'll make it bigger in a second. First, let me delete all the crap. Is that big enough, or maybe one more? That's good? Okay, cool. So let's start coding some demo. What is the basic workflow in a bike shop? Well, there's selling bikes and there's repairing bikes. Let's focus on the latter. So we're going to repair bikes. So what we want to model is, this is getting worse. What we want to model is, you bring your bike in the bike shop, tell me what's broken, and I'll kind of like offer you to fix your bike. So there's like a contract where we both agree, like, this is what I'm gonna do on your bike, and here's how much you're gonna pay for it, right? So the keyword we use in demo to add those smart contract templates, they're not actually contracts, they're just like templates, right? Because there's like some data missing, is template. And let's call it a bike repair. Let's use more spaces, then I think it's easier to follow where the stuff is. Okay, so there's a bike shop involved in a bike repair, right? And there's a type in demo called party, and you can think of as a party as like illegal entity in real life, kind of like the ledger, like the blockchain representation of what would be a legal entity in real life. So there's a bike shop on one side, and there's the owner of the bike on the other side. And then there's a description of what needs to be done. Let's just like say it's a text. Could be more fancy, but let's keep it simple. And then there's a price to this whole thing. And that's just like a number with 2 decimal places. And what else is there? There's like a due date until when you have to pay the bill. So like after I repaired your bike, you have to pay for it, right? So that's gonna be a date. Okay, cool. So that's pretty much declaring the payload of what will be in a bike repair contract when it's on the ledger. And what we care about in the distributed ledger space is kind of like, we want to make sure that everything that is recorded on the ledger has been signed by all the parties involved. So otherwise, if you have not signed something, you cannot be held accountable to it. The way we declare in DAML who has signed something is we say they are a signatory. And for this whole thing, there are like 2 parties involved, right? Like the bike shop has an obligation to repair the bike, and the bike owner has an obligation to pay afterwards. So there are 2 signatories to this contract. There's the bike shop, and there's the bike owner. Whoop. Okay, cool. So that's our first smart contract template. It's very simple. Let's try to put it on the ledger. And we run an in-memory ledger in this IDE for demonstration purposes. So let's write a small test for this, and we call our test scenarios. Autocomplete. So we need 2 parties. Kind of like we need to allocate the parties. We need to introduce them somehow. So there's a bike. There will be a person who owns the bike. Let's say Rohan wants to become a keen cyclist, but his first bike is broken. So, and then there's a bike shop. Well, I said I would run the bike. So there's like Doctor Who Villos. That's the bike shop. Okay, so that's the scenario. And we can run the scenario and nothing interesting is happening here. I just keep it open on the side. So what we want to do is, Rohan brought his bike to me in the bike shop, and I want to put a contract on the ledger saying here's an agreement that I repair his bike and he pays that much money. So what we want to create is like an instance of the bike, how did I call it? Repair, which will be a bike repair. And this whole with thing you've seen above here already is like another way for Haskell record syntax. So instead of saying like with and then listing the fields, we could use the curly brace syntax from Haskell. Oh, and there's another difference I haven't mentioned. We use single colons rather than double colons. We fixed Haskell. Cool. So we need the bike shop on the bike repair, and the bike shop is my bike shop. And we need a bike owner, which was Rohan, and then we need a description. I think Rohan has problems with, he just started saddle too hard. Sorry. We need a price to fix this. Let's say it's cheap. It's 50. And then we need a due date. So we don't want to take that into the new year. So let's say it's like December 31st this year. Okay. And now we want to create this on the ledger. So it means like we need to submit a command to the ledger that we want to create an instance of this contract template. And I want to do this. So let's say submit my bike shop, do, and what we submit is create bike repair. Okay. There's some feedback on the right hand side, which tells us the execution failed with the create failed because Rohan has not authorized what is happening. Okay, so like kind of like I try to create a contract which I have signed and Rohan should have signed, right? But Rohan never signed anything, so I just like can't force him into the position of owing me $50, which is very sad for me, but good for him. So let's fix this. The way we fix this is this workflow is kind of like an offer and accept pattern, right? Like I offer him, like he comes to my bike shop, says, I want to get this fixed, and I offer him, I'll fix it for you for $50, and he accepts my offer, and then we have a contractual agreement. So what we need is we need a bike repair offer, and what's in there is pretty much just the bike repair I'm offering. Oh, thank you. Cool. So we need a signatory for this one as well, and because the bike shop is the one who's offering, it will be the signatory. Bike shop dot. No, I'm not doing what I'm saying. No, bike repair dot bike shop. Okay, cool. You see something nice new about DAML? We have like proper record accessors, right? If you want to access a field in a record, you just like write dot and then the field name, like in pretty much every other language on this planet. Okay, so I feel like, can you still hear me, Ryan? Okay, it's different. It's different for me now. Cool. You want me to say something? Okay, cool. I guess I can just speak loud enough for this room, can't I? Can you all hear me still? Okay, that's cool. Okay, so this bike repair offer represents my offer to repair the bike, and Rohan needs a way to accept my offer. And in DAML, we model this with choices. So there's a choice called accept, and it will return a bike repair offer, a bike repair in the end, and like it will return the ID of the bike repair on the ledger, not just the data, but like an ID. Here we have it on the ledger, and you can reference it that way. So a contract ID of a bike repair, and the person who can like exercise this choice or execute it is called the controller, and in this case it's the bike repair dot bike shop. There's actually no need for these brackets. And what we do in this choice is we simply create what has been offered. Cool. So
While we're at it, why don't we put the radio up here? I think we'll get a better reception.
okay. Woo. Okay, cool. So one thing that happens when we create this bike, like when we exercise this choice, it's not only going to create the new bike repair contract, it's also archiving the bike repair offer, right? Like, whoa. Can I still talk? Yeah, okay. So my offer is not valid anymore after Rohan has accepted it, right? Like he cannot just like accept my offer twice. There's no double spend. So when he accepts this offer, it will be archived, and instead we will have the bike repair. Cool. So let's put this into a workflow. So what I will create is not the bike repair, but a bike repair offer with bike repair. Okay, cool. Now we finally have our first contract on the ledger, which is the bike repair offer. It says, I'm the bike shop, Rohan is the bike owner, his saddle is too hard, he has to pay 50, and he has to pay until New Year's Eve. Cool. That's great. Now we want Rohan to accept the offer. So what he needs to do is he needs to exercise his accept choice from above, and for this purpose he will need a reference to the offer I sent him. Let's record this as the bike repair offer ID. So, and what we will get back is a bike repair ID on the ledger. So Rohan does calls an exercise on the bike repair offer ID, and he calls an accept. Something went wrong again. Damn it. What happened? Attempt to fetch or exercise a contract not visible to the committer. Oh yeah, we care about privacy as well. So kind of like when I created the offer, I didn't tell Rohan about it. Like it's just like on the ledger, but he never saw it. So what I need to do is I need to allow him to observe the offer. So I just do that by adding him as an observer. Okay, now it still failed, which is surprising. Authorization is missing. Can somebody see what I did wrong? Oh, yes. Thank you. That's what you wanted to say, right? Okay, that's exactly the issue. Thank you very much. Okay, cool. As a result, we finally have the bike repair on the ledger, not the offer, but the repair itself. And we also see that there's the offer, which has been archived. Okay, so we have our first proper contractual agreement on the ledger. Nice. What we want to do next is we want to pay this stuff. So we need some notion of cash on the ledger, which represents cash in the real world. And we do this pretty much by something very similar to the bike repair. So there's going to be cash, and cash usually has an issuer, which is a party. Somebody owns the cash, which is another party. There's going to be an amount, which is a number with, let's say, 2 digits after the dot, and there's a currency. Oops. So we need a currency type. currency, and well, I don't know what's there. There's dollars. I'm from Switzerland, and I'm also from Germany, and maybe there are pounds. Okay, so we have some currencies now, and cash will be signed by the issuer, because they kind of like can be held accountable, right? Like they owe, like the person who owes the cash, kind of like they get owed cash by the issuer. But like owning cash is also an obligation, right? You could, I don't know, move into a different tax bracket or whatever. So I just want to get like given money. I want to subscribe that, it's like sign that I get it. Okay, so now we have cash. Oh yeah, and everything is nicer if you have eek and show instances. Cool, so we have cash. What we want to do when we pay for the bike repair offer is we want to transfer the cash from one owner to another owner. That's the whole purpose of paying. So we do this by adding a choice to move the cash. So there's a choice. Let's call it transfer. And it returns a new cash thing on the ledger. So there's a contract ID cash. And we need to tell, like when we exercise the transfer choice, we need to say who's going to be the new owner, which is another party. And there's a controller. Well, we don't want the issuer to move our cash around, so the controller is going to be the owner of the cash. And what we do when we move the cash, we archive the old cache and create new cache with the new owner. So we create, and then there's this, which refers to this contract instance itself, but we want the owner field to be set to new owner. So the with syntax is record update syntax here. So all of this reads like very naturally. Okay, so now we have a cache contract that can be moved around. We need to create cache on the ledger, right? And we're going to run into exactly the same problem as before. There are two parties who need to agree on the cache. Kind of like the issuer offers me, here's some cache, you want it? And I can say yes. But it's not like I can create cache, right? That would be cool. So we need kind of like this offer workflow again, which is sad because it would end up in boilerplate. Unfortunately, we have like a new shiny feature in DAML, which we call generic templates, which allows us to abstract out this offer, offer accept workflow. And let's do that. So what we're going to do now is we're going to create a template offer, which contains another template. Let's call it payload. Or, I don't know. Let's call it T. We love one letter variables. Okay. So when I offer something, there's like, I don't know, like the subject or like the offering, which is the T, and there's the party who's going to receive my offer, which is another party. Okay, so who needs to sign the offering? Yeah, so there's no issuer in offering. That's the problem here. Any other ideas? Okay, so I guess I didn't tell you signatory is not only a keyword to introduce signatories, it's also a function to get the signatories of something. So we take the signatories of the offering, but we remove the receiver. So everybody except for the receiver needs to have like signed what we're offering. An example of cache, if we make the owner the receiver, then only the issuer would be the signatory in this case. And looks like we need the DA list module as well. Cool. Oh yeah. So all of this only works if T is a template. So, okay. Now, we have a generic offer, and we need a way to accept it. And it works pretty much like the bike repair offer, which we can remove now. We won't need it anymore. And what will be in here will be the receiver, and it will create the offering. Okay, so now the bike repair offering is gone. You mean here? Yeah, that's a good point. Yeah, we want to create a T, right? Cool. So this whole DAML thing compiles to an intermediate language, which we call DAML LF, standing for the ledger fragment. And there is no such thing as generic templates. So what we need to do here is we need to do something like template instantiation in C++. So we need to like monomorphize this whole thing, and we need to give it a name. So what we do is we create a template instance, and we call it bike repair. Oops. Bike repair offer, which will be an offer for a bike repair. Ooh, yeah, we don't want to repair the bikers themselves. Thank you. So, and here we need to create an offer with the offering being the bike repair. Oh yeah. And we need a receiver, right? And the receiver was the bike repair dot bike owner. Oh, now we get this. Something about is not visible again, meaning we need to add this observer thing to the offering. Observer, receiver. Okay, cool. We finally have our bike repair back. And if we look, there's a bike repair offer on the ledger, which has been archived as well. Okay, so now we have like solved the problem of creating cache. Let's create some cache. Let cache equals cache with issuer. We need a bank. I don't know. Let the central bank issue the cache. And we need an owner for the cache, which is going to be Rohan. And we need an amount. Let's say it's 50, which is exactly what he's going to pay for the bike repair in the end. And then we need a currency, which is going to be US dollars. Okay, so now we need to create cache pretty much the same way we created the bike repair. So there's going to be a cache offer ID, which is, and now the bank needs to offer Rohan the cache. So create offer with offering is cache and receiver is cache dot owner. What did I do wrong? No instance for offer instance cache. Oh yeah, right. So I said we need to do these template instances if we want to use it. So now we're trying to use an offer for cache, so we need to do the same thing. Template instance cache offer is an offer for cache. Okay, now we have a cache offer on the ledger, and Rohan happily accepts that. So there's a cache ID. Where he exercises, which he gets by exercising the cache offer ID and accepting it. Okay, cool. Now we have the bike repair and the cache on the ledger. What we need to do is we need to find a way to put it into, like, to put this cache into this contract and make it like disappear. It has been paid. The way we do this is we add another choice to the bike repair template, which is gonna be called, I think pay sounds good. And we don't really care what it returns. No, yes. And what we need to pay into, like when we exercise this choice, we need to provide cash, right? So Rohan needs to provide cash when he wants to pay. And what we do in this choice, we need to check the cash actually matches what we expect for our bike repair. So we need to, first of all, we need to get actually dereference the contract ID, get the payload of the cache we've been given. We do this with a fetch. And then we need to check, okay, he's giving us cache he actually owns. He's giving us the right amount. And he's giving us dollars, right? We don't accept, well, I think everything else in this list might be more than dollars, but yeah, we want dollars. So we want cache owner is the same as the bike owner, and we want that the cache amount is the same as the price, and we want that the cache currency is USDs. And when we've done that, we need to transfer the cache. So we exercise on behalf of the we exercise the cache ID, and we call transfer with new owner bike shop. Okay, does that make sense to everybody? Okay. Whoops. So let's finally pay the bill. So what we do is we do bike, Rohan pays the bill by submitting an exercise. Exercise bike repair ID, and then pay with cache ID. And something is broken. Where is it broken? Oh yeah, we have the wrong return type here. And we forgot to give the controller for the pay choice. Controller is the bike owner. Okay. Now we have again something not working. Okay, I need to wrap my head around this. Oh yeah. So what Rohan is trying to do here is he's forcing me on this thing above here. If we just look locally at this contract, Rohan is forcing the new owner to take the cash, right? That sounds bad. As I said, cash might have negative impacts, right? So what we want to do here is we do not only this transfer does not only need to be authorized by the previous owner of the cache, it also needs to be authorized by the next owner of the cache. So they kind of need to exercise this choice together. So we do this by saying the controller is the owner and the new owner. And now everything has worked. So what's on the ledger? There's cash issued by the Fed to my bike shop, and it's $50. That is exactly what we wanted. We also have the bike repair, which has been archived. The bill is gone. Yeah. Cool. That's exactly what we wanted. Does all of that make sense? Do people want to see more of DAML, or does this whole authorization missing thing make sense? Pretty much, yeah.
So what's the relationship between controllers and signatories?
There's on a single template, there's no relationship, But if you want to exercise a choice, you need the authority of all the controllers. And when you're in it, you're exercising a choice within another choice usually. And the authority you give to the choice you're exercising is the authority of the controller of the choice in whose body you're, and the signatories. Does that make sense? Kind of like the signatories have authorized that the thing exists on the ledger, and the controllers of this outer choice have exercised that it gets, have authorized that it gets exercised, and this the union of this authority gets passed into the body. That is pretty much what is happening here for this. Where are we? For this transfer choice, right? To create this new cache, you need the authority of the new owner and of the issuer. You get the authority of the issuer because they're signatory of the contract you're exercising on, and you get the authority of the new owner because they're a controller. Cool. That's pretty much how authorization flows in DAML. Yeah, very good question. I should have made this more clear. Cool. More questions before we move on? Yeah? Yeah. So the idea is if you're a signatory to a contract, means you have you must have signed it at or you must have signed something along the way to get there. Yeah. More questions? Okay, then let's move on and look at how we build all of this. Where's my nice Kanban board? So this is done. And we talk about the compiler now. Meaning we go here. So, let me take a sip of water first. So let's recall how the GHC compiler pipeline looks like. It's, I'd say pretty much a standard pipeline. You start with Alexa and the parser. Then you run the whole thing to through the renamer, which does name resolution, and then you run it through a type checker, which does type inference and type checking. If you use template Haskell, you do multiple loops of this. If you don't, you don't. After this, you run it through the desugarer, which removes lots of syntactic sugar, like do notation. Type classes get turned into dictionary parsing. These sorts of things are happening in the desugarer. Then we have a simplifier, which works on the GHC core, which has been produced by the desugarer, and simplifies it, like inlining small functions, or if you have a case expression where the constructor of the scrutiny is known, then you pretty much know in which branch you are, kind of eliminating all of this stuff. Then the simplified GHC core gets converted into another intermediate language called STG, which stands for Spineless Tagless Graph Reduction Machine. Out of this STG code, we generate C++, which is an imperative intermediate language, and then we turn this one in the end into assembly. There are at least two paths for this. You can go either directly to assembly or you can go via LLVM. So this is the GHC pipeline. This is what we started with and modified. And here is how we modified it. So let's go from top to bottom. The pinkish things is the stuff we have not, are the components we have not touched at all. All the blue stuff is our stuff, and then there is the blue pinkish stuff at the top, which is the Alexa parser. So apparently we have syntax on top of what Haskell offers, like the template keyword, the with keyword, things like that. How do we do that? First of all, we changed Alexa and the parser to get them in. So there's a template keyword now, And when we see, like in the parser, when we see a template, what we do is we take this, look at like all the stuff that's like in the template body, and turn it into a bunch of type classes. So we rewrite stuff in the parser into type classes and type class instances and data types. So we take this whole template thing and rewrite it into like vanilla Haskell stuff. So after parsing, there's no more demo specific stuff left that is not expressible in plain Haskell. We then run this whole thing through a preprocessor, which currently does things like the dot notation we have for record accessing. There's a proposal to incorporate that into GHC itself, which would make our pipeline a bit simpler. We can remove it from there. We also do things like checking for modules you should not import directly, or we have to forbid like some specific data type declarations which we cannot translate into our intermediate language for various reasons. Then we run this parse tree, like this pre-processed parse tree, through the vanilla renamer and type checker. And before we did all of this magic, we had a custom compiler, and the biggest source of bugs were the renamer and the type checker in there. So we're really, really happy to just like use this battle-tested renamer type checker from GHC. It's removing a lot of maintenance burden from us. It has removed plenty of bugs. Yeah, so this was highly beneficial. After that, we take the type checker tree and pipe it through the vanilla desugarer, which is also very handy. One thing we did not have in the old, with our custom compiler, are nested like type classes and nested case expressions. I forgot to mention that the desugarer also unnests nested case expressions, which is a pretty complicated piece of software as well. So by using the desugarer, we pretty much got type classes for free, and we got like nested case expressions and all stuff around this, like view patterns, for instance. We got all of this for free in our language, which is very nice, which would have taken, I guess, a few people years to implement all of this in a very sound fashion. Cool. Then we take the GHC core that has been produced, and we transform it into our intermediate language called DAMLF. What is DAMLF? It's pretty much system F, so the polymorphic lambda calculus, plus a bit of stuff which is specific to smart contracts. We have ways to declare templates and choices. We have primitives to exercise, to create contracts and to exercise choices. That's pretty much all we have on top of system F. And well, we have like a bunch of other primitives, like, I don't know, add two numbers and built-in types. Yeah. So how do we take the desugarer, the desugar GHC core, which does not know anything about templates anymore, into DAMLF, which knows templates? Most of the translation is straightforward because GHC core is pretty much system F C. We don't do the C, so you can't have GADTs, for instance, in DAML. And on top of this straightforward conversion, we look for those type class patterns we created in the Lexa parser. So they're like, we look for specific patterns of type classes with specific names and specific instances of them, and like re-sugar them into the templates you pretty much wrote in the surface language. So we kind of like turned them into plain vanilla Haskell in the Lexa parser, then used the whole pipeline without any hassle, and then we suck it out again at the end, nicely type checked. After this, we do some post-processing on the DAMLF, like simplifying some stuff, interning some constants, things like that. Then we encode this whole thing into protobuf messages. So our whole, like our compilation artifact is like a huge protobuf message. And in the end, we take this plus all its dependencies and put it together in a zip file. That's the compiled artifact you get from the compiler. What else do we do? What you've seen in the IDE, what I've probably not shown is we have nice things like go to definition. Where's my IDE? Here's my IDE. So let's hope it works. So here, let's take this one and go to definition. Here we go. So that is one thing, and the other is, well, we have type annotations to some extent. This one doesn't make too much sense. It's leaking implementation details, but like here you can see like my bike shop is a party. How do we do this? We look at the type checker tree to like figure out all this information. So we kind of like our IDE pings our whole internal state we build and looks at the type checker tree to like figure out where something being defined. The right hand side is not particularly interesting today. Another thing we've seen in action is the scenario service down here, which is what we've seen here. So that's the result of the scenario. So like running the scenario through our interpreter for DemoLF. Yeah, so what we do is we take those protobuf messages, ship them, not really over the wire, we ship them over to a Java or to a JVM, which then runs an interpreter for the DemoLF. Our whole DemoLF runtime is written in Java because enterprise customers seem to love Java and want to deploy Java, so the whole runtime side is written in Java. Yeah, that's the same. Yeah, it's written in Scala. Some parts are still written in Java, I think. Yeah, good point. Oh, yeah, I don't know. For me, it's equally bad. Oh, I said that on public record. Damn it. Okay, so this is how we took the Ghz pipeline and modified it into our demo compiler. And another thing we did is we hooked up this whole thing into the IDE you've seen, which is built on top of Neil Mitchell's Shake library. So what we've done is we've taken pretty much Shake, built an in-memory version of Shake. I guess Shake is like this make system library, like if you or build system library written in Haskell by Neil Mitchell. You can build your own build systems if you want to. And we've taken this, made an in-memory version of it. We put the language server protocol on top and turned that into an IDE. And this IDE is very modular. There are like some rules that are specific to Haskell, which are like this whole lexer, parser, renamer, type checker, and desugaring thing. So they're like rules. And we've actually taken like this top half of the pipeline and open sourced it as a library called Ghz IDE, which I don't have a link to in this presentation, which is very sad. So yeah, like the top half of this picture can be used as an IDE for Haskell, which has go to definition, type checking, tell me the type of this thing. If you haven't seen it, check it out, it's cool. And then we've extended this Haskell or this Ghz IDE, which used to be called Haskell IDE Core, which it no longer is. We've extended it by adding more rules which are specific to demo, which are the bottom ones here. And what you've seen in my demo is I've connected VS Code to this whole IDE language server protocol service. And we have extended VS Code a tiny bit to get the scenario links working. Yeah, so that's pretty much how we built the IDE and the compiler. The command line compiler is also driven by this shake-based rule system on the right-hand side. Yeah, that's how we get people who love demo. So I consider that being the part talking about the compiler done. I'm not ready to answer questions yet. There's one more thing. You might be wondering where to go from here. There are many things. So if you want to play with DAML, please go to our website, daml.com, download the SDK, install it, and then you pretty much get the IDE experience I showed today out of the box. If you want to continue on the bike shop, working on the bike shop example or having another look, you can download it. There's a gist on GitHub. It's not exactly this one. It's the Swiss version of it, not the American version. If you actually want to work with DAML, we have a pretty good documentation website, so please go there. If you're interested in what we're doing now, what we'll be doing in the future, you can follow us on Twitter. If you like the dot syntax for records, remember bike shop dot bike owner. As I said, there's a proposal to incorporate this into JHC. You can find it under this link. And please upvote it if you like it. We'd like to get many supporters, so we get it through the committee. If you liked what you saw and want to work with us on making it even better, you can apply as a language engineer. As I said, we're looking for people here in New York. If you don't want to work as a language engineer, but still help the whole DAML story, there are other open roles. For instance, the team which does DAML as a service is looking for people as well. Talk to Max about this. This whole DAML thing is an open source project, so if you feel like contributing, we'd be very happy. Just go to the website. If you enjoyed playing with DAML and want to put it in production, deploy it somewhere, there's Project Dabble, which is this DAML as a service. And if you like to have a look at how we built this Kanban board based on DAML, there's a link down there as well. Okay, so let's move to all the questions you have. Thank you. Yes.
So it seems like you're really only using, I say only, you're using the resugar, using the Elixir bit, the desugar, and the time checker.
Yeah.
You name it. So was this the reason that you developed GHC lib parser and open source that?
Yes. So there's, oh yeah, I forgot to mention it. There's so much stuff. There's GHC lib and GHC lib parser, which are a small tool to turn GHC into a library. So GHC lib parser gives you everything until the parser, which is used by, we're currently working on integrating it into HLint. And GHC lib gives you the whole thing until after desugaring.
I think Armolu also uses it now. I was looking at this the other day.
Yes, it uses GHC lib parser. Yeah, they switched recently. Yeah, yeah. So, yeah, it's a way to package GHC as a library, which is convenient right now. If you use GHC, there's you get GHC as well, but you get the version of GHC you're currently using, right? You might want to compile your project with GHC, I don't know, 8.6, because you need to, but you want to get build something for GHC 8.8, for the newer Haskell supported by GHC 8.8, so you can compile GHC 8.8 with GHC 8.6 as a library. Oh yeah, unless you do template Haskell.
I help maintain iHaskell, which is why this is relevant for me. I'm the only person in the world for whom this is a concern, it seems like.
Oh. You want to do template Haskell?
No, because I actually need to run the code.
Oh, I see. So you need like the full runtime. Yeah. I guess you can like go even further down in the stack if you want to, right? I don't know, like GHC lib runtime. Yeah. Cool. More questions? Yeah. Yes. So some of them used to be Haskell developers. They like it. They go crazy about it. There are other people who've never seen Haskell before. They like, for instance, like some people like MDs in banks seem to be able to read it. They look at like a contract workflow and can tell you where there are bugs, like in a buggy contract workflow. So it seems to be well received by business analyst people. Yeah.
Also, like at least one big team of software engineers using it who are not Haskell developers for the most part, like mostly like more people doing more traditional languages or JVM type people who I think there's definitely a learning curve, but they really take to the functional programming kind of concepts and which Dapple uses.
Yeah.
Overall, non-Haskell people have also have pretty positive experience.
Yeah. I think there are like some parts which are harder, like, I don't know, you need to teach people about monads to some extent, which apparently people are afraid of. That's why they're not called monads in YAML, but actions, which made it maybe a bit easier for them to understand it because you like, I don't know, remove the big scary word from the conversation. I think that is like an area where people struggle a lot. Then like the lack of mutation is something people struggle with, but kind of like on a ledger you don't really want mutation, right? The most you want to have is like very local mutation. So I think like removing it from the language completely is a good thing. And it takes people a while to get it, but I think all the people I've seen who use it like got along with it in the end. Yeah. Depending on where you're coming from, I think there are like some obstacles, but yeah, people seem to pick it up. Yeah?
So when you have compile time errors, what code statements, what language code statements?
They are in Haskell, but like to a very large extent they are the same, right? Sometimes you get like some externals get internals get exposed, like if you call a choice on a template, try to call a choice on a template which doesn't have a choice of this template, it's going to tell you like an instance does not exist. We consider this temporary, like in the long run we want to fix it, but it has not been big enough of an issue yet. Yeah. What we fix is like your types in your error message have like a single colon. That would help us a lot, yes. Okay, no, we're not involved with that yet. But yeah, it's good to know. Yeah. We're also like secretly hoping, I don't know, like the trees that grow thing gets like somewhere where we can actually like put our custom syntax like into like the growing nodes of the AST, and then we might be able to produce like error messages ourselves, right? But I guess that is at least a few years away from now. Yeah. More questions? Yeah.
What does DAML stand for?
That's a good question. I can tell you what it used to stand for first. It used to stand for Digital Asset Modeling Language. Like not digital asset as in the company digital asset, but like a modeling language for digital assets. And so it was associated very much with the digital asset, and then we decided to open source it and said, okay, it stands for DAML. Kind of like we already had a name for it, but it didn't really matter what it stood for. So yeah, right now it stands for DAML. Yeah. Maybe it's also the distributed abstract machine language. I don't know.
All
More
right, guys, one more big round of applause for Martin.
Thank
Thank you.
you.
We're gonna wrap things up. We're gonna go to Arlo. Arlo is right around the corner. You guys could Google map it.